a way to go back over to relook at it. Question? You're good? Questions on any of the homework assignments so far? So half of this, because I gave you the worksheet, so you could go on and do 5 through 8 because we've covered those. We just haven't gone over 1 through 4 yet. Because 1 through 4 is asking you to identify the vertex, focus, directrix, and axis of symmetry from the given equation. And that's what we're going to be looking at today. So when we look at this first problem here, the first thing we need to do is to find the vertex. What we're going to do is end up finding vertex, focus, directrix, and axis of symmetry. And to be able to find that, we need 3 pieces of information. We need the value of h, the value of k, and the value of p. Because if we know the value for each one of these here, we can find the focus, directrix, axis of symmetry, and directrix. We can find all these pieces of information because each one of them is dependent on the values of h, k, and p. Because once we have those, we can plug them in and solve. Now, the first thing we want to do when looking at this equation is match it up with its general form. So we have y equals 1 over 8 times x minus 3 squared plus 2. So this is y equals, so it matches our y equals 1 over 4p times x minus h squared plus k. These two here match up. These are the same. Since we have y equals, it's going to be our y equals equation. Now we need to use this to find the values of h, k, and p. Well, our plus k on the outside lets us know that the value of k in the equation for this here is going to be our, matching up to our plus 2. So the value of k is 2. Our x minus h matches up with our x minus 3. And our value of h would be 3, because it is opposite. Since we have minus 3 inside, it's going to come out as positive 3. So we have h is 3. Now at this point here, the only thing we're missing is the value of p. And to find it, we need to match it up with what we have. Now, in our general equation, p is located in the 1 over 4p. But what is that matching up with in our equation that was given? 1 over 8. Now, whenever we plug in the value p, or whatever the value p, when plugged into 1 over 4p, should turn it into 1 over 8. So what we're saying is that for this here, that 1 over 4p is going to equal 1 over 8. Because our 1 over 4p, we'll set it equal to whatever's in front of our parentheses. Whatever the number is, we'll set it equal to it. Questions on any of this here? Questions on how we found the values of h and k? Questions on how we set up our 1 over 4p equals 1/8? No? Now our first step in solving for the value of p is always going to be the same. We're going to multiply both sides by 4p. Now I'm going to work this all the way through so we see how this works, but we don't have to do these same type procedures every single time. Because normally when we multiply 4p by 1 over 4p, the 4p and 4p will cancel. But part of the reason for that is because if we multiply 1 over 4p by 4p, we do this multiplication here. The 4p multiplies with the numerator, our 1, giving us 4p on top, 4p on bottom. On the other side, we're going to multiply the 1 on top by 4p. So we get 4p over 8. Now anything divided by itself, 4p divided by 4p is 1. Now the 4 over 8 will reduce to 1 over 2. Questions on any of this here? Now at this point here, we do need to solve for the value of p. So what we can do is multiply both sides by 2. Because if we multiply the right-hand side by 2, we would get 2p over 2. If we do the same thing with the left-hand side, 2 times 1 is 2. Well, the right-hand or left-hand side is still going to stay 2, but 2 divided by 2 is 1. Really telling us that the value of p is 2. Any questions on how we found the value of hk or p? Any questions on anything we've done so far? So we're good with finding hk and p so far. Now truly what we're looking for is the vertex, which is our point h comma k. Our axis of symmetry, which is for us here is the equation x is equal to h. Our focus, which for us is the h comma k plus p. And our directrix, which is our equation y equals k minus p. So these are the 4 pieces of information we're trying to find. Now our vertex was the point h comma k. Looking back at what they were given to us, the value of h is 3, and the value of k is told to us to be 2. So the vertex for this parabola is the point 3, 2. Our axis of symmetry, x equals h, will tell us that x is equal to 3. Our focus is the point h comma k plus 3. We still have h as 3, but we do need to calculate our k plus p. Well, the k value is 2. Our p value is also 2. And 2 plus 2 gives us 4. So the other value of the focus is 4, giving us the point 3, 4. And lastly, our directrix is y equals k minus p. Now we do have to calculate this one also. K minus p. Value of k is 2. P is 2. And our 2 minus 2 gives us 0. And that's it. So once we find the values of h, k, and p, we just plug them back in and we have the information that we need. Any questions on any of this here so far before we look at our next piece? Are we ready for the next one? So our next one is y equals negative 1/4 times x plus 2 squared plus 1. So here we're saying y equals 1 over 4p times x minus h squared plus k, because it's set up in the same form. Y is to the first, our x is attached with the second power, that's 2. And again, just like before, we need to find the values of h, the value of k, and the value of p. Because if we can find the values of h, k, and p, we can solve this here. Now, what is this telling us the value of k is? 1. What's our value of h? -2, because it comes from +2 inside. And I mean, for some of these, we can look at it and determine what the value of p is, but sometimes it's going to be helpful to actually calculate it out. And for us here, we're saying that our 1/4p is going to be equal to what? What is taking its place? -1/4. Questions on how we found h, k, or set up our equation to find the value of p? Our 1/4p equals -1/4. So when we look at this general equation, the 1/4p is where the p value is located, yes? What is the corresponding spot on our equation? -1/4. So we're saying whatever the value of p is, when we plug it into 1/4p, should give us -1/4. -1/4, yes. Now our next step is going to be the same for every single one. We're going to multiply both sides by 4p. And the reason we do this is we want that 4p that we multiply the left-hand side by and the 4p in the denominator to simplify. In this case, they're going to simplify to 1 because that's the numerator, simplifies down. On the other side, we're going to multiply these together. So we'll have our -1/4 times 4. Now we could do this in a calculator. Clear all that out. -1/4 times 4, which tells us it is -1. So we could say that we have -1 times p, but this is also the same as -p. So we were saying 1 is equal to -p, but we need to move or get rid of the negative from p. So we can either multiply both sides by -1 or divide both sides by -1, telling us p is -1. So it tells us the value of h is -2, k is 1, and p is -1. Now our vertex is the point h comma k. -2, 1. Axis of symmetry. Well, for us here, it's x is equal to h, so x is equal to -2. Our focus is the point h comma k plus p. Well, our h value is -2. But we still need to figure out what k plus p is. So we have 1 plus -1, which is indeed 0. And our last one is the directrix, which is our y equals k minus p. Well, the value of k is 1. Value of p is -1, so we have 1 minus -1, which is +1, which does give us 2. Now for your homework or the assignments, you don't have to write the general forms above it. I'm just writing those as a reference point back to what we're plugging in to get there. Are there any questions on any of this here? Questions on anything we've done so far? Are we ready for another one? Let's look at the next one here. X equals 1/16, y minus 3 squared plus 1. Well, the general form for this is x equals 1/4p times y minus k squared plus h. And we still need to find the values of h, k, and p. Now for this problem here, what is the value of k? It would indeed be positive 3.
Oh, I just look at the red. I don't know why I red.
The one outside the parentheses? Oh, yeah.
I just look at the red equation. Positive 1.
Well, what is the value of h? Positive 1.
I just looked at the as if it was just a I keep looking at red and not the
Right. Now, in x equals, the h and k value do flip. Because in the ones we had before, the h value was inside the parentheses and k was outside. For this one here, the k value is inside the parentheses and h is outside. Now, one thing that's interesting is that the k and y always go together. Because when we talked about vertical translation moving up or down, we've moved that amount of transformation in for k, how far it's moving up or down. And when we moved a function left or right, we plugged it in for h. H is always going to be attached to x. They're going to go together, and k is attached to y. That's why, for this one here, the k is inside the parentheses, because y is. And on the last one, x was inside the parentheses, so h was too. Any questions on how we found the values of h and k? I think for the most part, we feel pretty comfortable finding that, yes? So before we go on, let's see here. For the vertex. Well, the vertex is our point h comma k, yes? Well, what would the vertex be? Okay. Axis of symmetry for this one here is y equals k. You're good? Y equals 3. Yeah, because for this one, because we're looking at the other equation, we have y equals k. And the one before we had x equals h. Focus. For us here, the focus, if we look at the general form, h plus p comma k. Now, do we know what p is? No, because so I can't solve for h plus p, but I do know what k is. K is 3. And the directrix is x equals h minus p. Well, I still don't know what the value of p is, so I can't calculate that. Well, out of the 2 points, I do have 3 out of the 4 values, yes? Out of the 2 equations, I have one of them. Just being able to find the vertex, or the h and k, have we found essentially all of the points, or most of what we need? Yeah. So even if you do get stuck on one of these, you can get most of the data, most of the answers just from h and k. Now, the value p for this problem is located in our 1 over 4p. What does that correspond to, R? So we're saying that whenever we plug in the value p into 1 over 4p, we should get 1 over 16. Questions on how we set this up? Now, what do we need to do first in solving for the value of p? Times both sides by 4p. Now, the left-hand side will simplify to 1, and that's mainly because the numerator is 1. Yeah, no, you're good. Because here the numerator is 1, so it just simplifies to 1. If it had been 3 over 4p, it would have simplified to 3. But in most cases, it's just going to simplify to 1 for these. On the left-hand side, we will still have p, but we do need to multiply our 1/16 and 4. Which we could do this in a calculator. 1 over 16 times 4 is 1 over 4. or we could call it P over 4, because we multiply with the numerator, so P over 4 or 1/4 P. Questions on this here? Either works. Question? Yeah, because we could call it 1/4 P or P over 4. Either one are the same thing. But the key is to simplifying that fraction. We want to get the P by itself. So here, we're multiplying the P by 1/4, yes? The other case, we're dividing P by 4. It's the same thing. P divided by 4. How do I undo division? Multiplication, yes? So what can I multiply both sides by? 4. Because just like with multiplying both sides by 4P, if I multiply P over 4 by 4, we get, really, 4P over 4. All 4 over 4 is 1P, yes? Anything divided by itself is 1. But if I do it to one side, we have to do it to the other. And what is 1 times 4? So P is 4. Questions on this here? Now, if you feel like you might have done something wrong with finding the value P and you want to check it, again, what did we say? Whenever we plug P into 1 over 4P, we should get what? 1 over 16, yes? So I can grab a calculator and say 1 over 4 times 4, our value P, we get 1/16. Now, I'm just jumping back to the last one. We said on the last one our value P was -1, yes? I can plug it in. 1 over 4 times -1 is -1/4, yes? What do we say the number in front of that parenthesis was? -1/4. It still matches, doesn't it? So that means we got the correct value of A. For the very first one we did, we got 1/8, yes? We said the value P was 2. So here I can say 1 over 4 times 2 is, so we're able to verify those and make sure we got the correct value. Well, what are the only two places we're missing? The H plus P and H minus P, yes? So H plus P, well, H is 1, and 1 plus 4 is 5. So our focus is the point 5 comma 3. The directrix is H minus P, 1 minus 4. 1 minus 4 is -3. Questions on this here? We're starting to get a little more familiar with this. Now for this here, again, is revolving what? Around the general forms and being able to find our HK and P, because if we can find those, plug it in for the vertex, focus, directrix, and axis of symmetry, we have what we need. Any questions on any of this here? Any questions over anything we've done so far? Are we ready for the next one? Now this one here, we're back to y equals 1 over 4p times x minus h squared plus k. So we still need to find the values of h, k, and p. Well, what's our value of h? Yeah. because we're back, h is back inside the parentheses. So it'd be -3. Our value of k would be, since it's outside parentheses, it's exactly what it looks like. Since it's -5, it would be -5. So just as we saw in the last one, we do have we have enough information to fill in pretty much all of it except for 2 places. But before we do that this time, let's go on and find the value of p. So to do that, we're going to have to set 1/4p equal to, it wouldn't be 0, because if it's 0, that would cancel most things out. It would be 1. Because if a number is not stated, it's understood to be 1. So there is a 1 there, we just don't write it. Questions on this here? Now the first thing we need to do is multiply both sides by 4p. And again, just like all the ones before, at least all the ones today, that side simplifies to 1. Now 1 times 4p is 4p. Now what do we need to do to get p by itself? We need to divide both sides by 4, telling us p is 1/4. Now if I wanted to check this, we could do 1/4 parentheses 1/4, enter, and it does indeed give us 1. Now our vertex is the point h comma k. Well, our h value in this case is, and our k value is, so -3, -5. Our axis of symmetry for this here is our x is equal to -3. Our focus is our h comma k plus p. Well, the h value is still -3. Now our k plus p, well, our k value was -5 plus 1/4. As tempting as it is to say that -5 plus 1/4 is -5 and 1/4, that's not the case. Well, -5 plus 1/4 is -19/4, or -4.75. I'm just going to write it as -19/4. You can write it as -4.75, or it is -4 3/4. Because we're adding a positive and a negative together. And lastly, our directrix. The general form is y is equal to k minus p. All right, so our k minus p would be -5 minus 1/4, which is similar to what we had. -5 minus 1/4 gives us -21 1/4, or -5.25. -5.25, or it's a mixed number, it's -5 and 1/4. Questions on this here? Questions on anything we've done so far? I'm going to give you some time to work on those. We will finish this tomorrow.